Hi everyone, thanks for having me at SecJuice. My name is Ashish Bhatti, and for the next 15 minutes, I want to talk to you about a problem that almost every security team has, but almost nobody measures and almost nobody has a good tooling for configuration drift on a Microsoft Defender and a small open source framework that I built. It's called DCAT that tries to do something about it. This title tells you the whole thesis. We're going to treat Defender hardening not as a one-time deployment, but as a code, reversible, auditable, and version control code. So let's start. Let's dig in. Here's the gap that motivated the whole project. The most security teams I talk to can tell you in detail what their endpoint protection is supposed to do. They have a baseline, they have a CAS document, they have an Intune profile. Far fewer of them can tell you with evidence what the endpoint protection is actually doing right now on the fleet and whether the gap between those two things is growing or shrinking over the last 90 days. That gap between the intended state and the observed state is the entire topic of this talk. Um, Now, when we say an endpoint is configured, what we usually mean is that at some point in the past, a baseline was applied, a CAS benchmark, Microsoft security baseline, or a vendor recommended config. It was pushed out, verified once, and then handed off to the IT operations. That's the ceremony. But configuration is a verb, it's not a noun. It's a state that has to be maintained, and most of the industry tooling and documentation treats it like one-time event. Nobody sets out the drift. Drift happens through accumulation. Somebody disables tamper protection on a subset of endpoints so third-party AV agents can coexist. Somebody flips an, say example, ASR rule from block to audit to troubleshoot a compatibility issue, and then the ticket closes and never reverted. A real-time protection exclusion gets added to quiet a performance complaint on a file server, and then it propagates through scope via group policy. Each of those is a reasonable local decision. Stacked together over a year, they are how you end up with a control that exists on a paper but only partially in practice. Let's make that concrete. Four scenarios, all of them ordinary, all of them things I have personally seen in production environments. Number one, an ASR rule defined as a block, quietly set to audit during troubleshooting, never reverted. Tamper protection disabled on a subset of endpoints for agent coexistence. Real-time pro- Real-time protection exclusion that propagated through scope. Co-management conflicts where Intune or MECM apply overlapping policies and nobody's sure which one has won. None of these are exotic. These are ordinary configuration entropy, and from an auditor perspective, it's actually worse than having no control because it creates a false compliance posture. You might ask reasonably, why doesn't the security stack catch this? We have all kind of tools such as SIEMs, we have EDR telemetry, we have Defender XDR. The answer is simply that those tools are designed to detect threats, and they're not designed to monitor configuration states. Defender XDR will surface threat signal and incident data beautifully. It will not natively alert you when an ASR rule enforcement mode changes from block to warn, a shift that meaningfully alters your attack surface without generating a single threat event. Configuration state is a blind spot in most shops. So, what would it actually take to close the gap? I argue you need three things. The most current tool chains give you one or two, not all three. Number one, a versioned, authoritative, definite definition of what the intended configuration is. Number two, a continuous or at least scheduled mechanism to measure actual state against the definition. Number three, a safe, tested pathway to remediate deviation without introducing any new disruptions. If you are missing any of these, the other two are materially weaker. Requirement three is rollback. Is one of the easy. That's one of the easiest to underestimate, and that's the one that actually unlocks the other two in practice. Security teams in production are rightly cautious about automated remediations. An aggressive enforcement mechanism that silently re-enables a blocked ASR rule can break legitimate business workflow. Fear of disruption leads to hesitation, which means that even when you detect drift, you don't fix it. But if remediation is structured in a reversible operation, if there's a known recovery path, the calculus changes. Teams are far more willing to enforce when they can demonstrate a safe reversion is available. The model I'm advocating is policy as code. This isn't a new idea in cloud. Um, eh, Things like Terraform, Azure Policy, AWS config rules, they already exist, but it's less frequently applied to endpoint security configurations. Applied to Defender, it means you define your requirement in a machine-readable format, a JSON manifest, a PowerShell data structure. You commit it to a version control. Then you use automation to apply, evaluate, and if needed, a rollback. PowerShell is actually a natural fit here, because it has some of the switches to manage Microsoft Defender already exists, such as set MP preference, get MP preference, get MP computer status, etc., which gives you programmatic access to Defender state out of the box. This is the toolkit I built on top of the model. I've named it DCAT, which stands for the Defender Control and Audit Toolkit. It's open source. It lives on GitHub. The link is in the next slide, or it should be in the end of the slide. Rather than shipping a fixed hardened configuration and leaving deployment to practitioner, DCAT structures the whole process around four explicit auditable phases. Phase number one is called capture. Phase 2 is apply, phase 3 is score, and phase 4 is rollback. And in the next few minutes, I want to talk to you about each phase briefly. So phase 1 is called baseline capture. Before you change anything, you snapshot the current state of the Defender on a target. Every preference, every ASR rule, mode, every exclusion, every real-time setting. That snapshot is saved as a structured artifact, timestamped, version, defiable. This is one thing you compare future state against. It's also critical, the things you would roll back to if something goes wrong. No snapshot, no rollback. Phase 2 is the policy application. You take a baseline manifest, you can have your own custom, or you can have a CAS aligned, and you apply it to it. The application is scripted, idempotent, and logged. Every change is attributable. You're not clicking through any GUIs. You're not trusting a group policy to merge correctly. You're simply executing a defined set of changes against a known starting state and recording what happened. Next phase 3, is one of the most I am proud of, this phase is simply called compliance scoring. Most compliance tooling gives you a binary results, either compliant or non-compliant. That's operationally useless. An endpoint, say with the 94% configuration compliance against CS level 1, is in a meaningfully different risk state than say the one which has 40% or 60%. But a binary report treats them the same. DCAT produces a code results output. It tells you which controls are aligned, which have drifted, and by how much. That granularity is what lets you prioritize. Phase 4 is one of the most important. It's called rollback. If your changes introduce any regression, if the help desk queue lights up, if a business unit escalates, you have a clean path home. The baseline from phase 1 is your safety net. Recovery is scripted operation. It's not an archaeological dig through change tickets. This is the future that makes phase 2 and 3 uh, psychologically safe psychologically safe to deploy in production. Without rollback, enforcement is scary. With rollback, enforcement is just a change you can undo. Now, let me illustrate why this matters with a case study. Attack surface reduction rules. With attack surface reduction rules, Microsoft provides 16 attack surface reduction rules in Defender for endpoint. Each rule has 3 modes: off, audit, and block. The CAS Windows 11 benchmark maps a subset to specific CAS levels and MITRE techniques. On paper, it's tidy. In practice, organizations they end up with patchwork. Some rules in block, some rules in audit, some disabled, spread across GPOs, Intunes, and local overrides that may or may not align. A security team that can't enumerate ASR enforcement state across their fleet with confidence cannot accurately assess their exposure to living off the land techniques. That's a visible problem before it's a compliance problem. Versioning ASR rules states tracking enforcement mode changes as auditable event turn this from an informal operational practice into a governed change process. This also connects directly to Zero Trust. NIST 800-207 describe policy decisions points and policy enforcement points that evaluate device trust being granting access. Device health is a key input, but the signal that typically feeds device trust, MDM compliance status, attestation, EDR health, generally don't capture whether the security tool itself is correctly configured. An endpoint can report as compliant to Intune while running with degraded Defender coverage because someone added an exclusion 3 months ago. The compliance signal is technically accurate and practically misleading. If you are doing a zero trust and you're not feeding Defender configuration state into your trust scoring, you are operating on an incomplete picture. The audit and forensic payoff is substantial. When baselines on version and compliance evaluations are logged, auditors get artifact-based evidence, a factual record of control state over time, not an in-point time screenshot taken during audit windows. That matters for SOC 2 type, FedRAMP continuous monitoring, or NIS2 in Europe frameworks that require evidence of control operating effectively, not just being implemented. And for the incident response, baseline versioning gives you a reference point to determine whether observed configuration changes are an attacker disabling security, which is known ransomware pre-deployment technique, or a legitimate admin change. The difference between these two scenarios are enormous implications for scoping and containment, and the determination is much harder without a known good baseline. Now, I want to be honest about the constraints. The approach is not a magic wand. Co-management complexity is real. If you have both Intune and MECM or group policy applying policies, automated enforcement needs to detect conflicting policies, sources, or you'll end up in a remediation and drift loop. PowerShell deployment is itself an attack surface. Scripts that modify security operations with elevated privileges need to be signed, deployed through a managed channels, and protected against tampering. The governance framework cannot be less rigorous than a control it manages. And in the air-gapped or OT environments, the assumption of connectivity to a management server may not hold. DCAT supports offline capable configurations, exports for exactly this reason, but practitioners should plan for integration work. So here's the question I want to leave the room with. It's not, is Defender configured correctly today? Any team can answer that with the screenshot. It's, do you have a process in place to know when it stops being? Because it will stop being. Drift is ordinary. The discipline in this detection is and reversal, not the initial deployment. If you're at any stage of Defender and deployment maturity, try DCAT. It's an open source. It lives on the GitHub. The link is in the screenshot here and the presentation slide here. Clone it, capture the baseline from test endpoints, run a compliance score, and see where your fleet actually stands. Um, and Any feedback and contributions are welcome. The goal of this project is to make Auditable Defender hardening accessible without specialized tooling dependencies. And that was the presentation, guys. And a quick word about me, and then I'll wrap it up. My name is again Ashish Bhetty, and I'm a senior systems engineer with over 20 years of experience across Australia, Canada, and US. My current work is in broadcast system security. I work for a live news and sports TV environment, which is an interesting mix of enterprise and operational technology. I research zero trust, AI assisted threat detection, security governance in OT context, and DCAT is one of my open source side of that work. Other than that, I also contributed to ISACA's employment committee, and I also work volunteer with Cyber Peace Institution, where I help different organizations who cannot afford cybersecurity. I help them out with their needs. And if you want to get in touch, the easiest way is to get in touch using the GitHub link I provided before. Thank you very much.